Hi, what's up, everyone? I hope you are doing great. Okay, so today I want to talk about something that completely changed the way I learn, and maybe it can help you too, whether it's CFD, FEA, or data analytics. Well, I'm currently learning data analytics, so I figured I was quite good in Python back then during the college days. So I want to transform that skill into something that's in demand, right? So currently NumPy, np.array, what.arrange, what. So the real key is master the concepts first, then what the software. In a time before understanding, in a land ruled by software, many dared to run simulations, but few knew what a turbulent model even was. They clicked, they meshed, they crashed. But then, from the ashes of failed simulations, a new learner rose, a seeker of truth, a breaker of meshing errors. His name, Nyasha. When I first got into simulation and engineering tools, I wanted to jump into software like ANSYS or SolidWorks. But I quickly hit a wall, especially in ANSYS Fluent. I didn't understand what I was selecting in CFD. Like, suppose you are copying a YouTube guy for, let's say, you want to simulate simple water flow in a pipe, right? So, following the like following the steps you would be laying out, you might not know what he is doing, right? Suppose on selecting the modules, you might select the SST K Omega, and you might be, I don't know what that is. So that's when I realized that I really didn't understand what was happening, right? Especially in CFD. uh, Luckily, the first thing I want to thank God is that uh, I wasn't caught by the Dunning-Kruger effect in terms of CFD. I quickly realized that, yeah, I know very little, and I have a lot to I need to learn, right? So I went back to the basics. I went back to the basics of even understanding what a fluid is, because I figured back in university I just wanted to pass, right? But this time I was really understanding what a fluid is, the definition in terms of shear stress, turbulence models, vapor pressure, those, anything that concerns fluid mechanics, until I finally got to the Navier-Stokes equations. When I got to the Navier-Stokes equations, I then really understood how the like K epsilon, K omega modules work. You see now how it's connecting, right? So mastering the concepts first will help you, especially in computational fluid dynamics. Not CFD, but FEA. FEA isn't just about stress score to force over area, right? There are also those equations you really need to know what's happening. I'm not a pro, but now I'm growing, and now I'm not just using the tools, right? I'm thinking like an engineer. I see how the theory connects to real world simulations and code, and that's powerful.